students, let us see the characteristics of sound wave. As I have told you that the wave is not just like the vibrations that we have seen earlier, like a compression and the rarefaction. But originally it is like that. But if we want to study that thing, so how does it possible for us to study a single particle like that? So what we are going to define it, we are like humans, we are very intelligent, so we can do any typical thing in a simpler manner. Okay, so here is the thing that we have created for ourselves for studying the thing. So what does it indicating? Like earlier we are talking like this, that this is a compression part in which the molecules and particles are very close to each other, and this is the rarefaction part, and the waves are moving from here to here. So again the compression part. So this is all generating that the waves and the particles are moving in this manner. Okay, so this compression and this rarefaction and this compression. Fine. So students, as you can see, compression, rarefaction, compression. Here we can generate a diagram accordingly, and we can say that when the particles are at the compression thing, so we will say that the pressure is high here, high pressure, and this is the pressure for low pressure, zone for low pressure. Okay, so we have created such a diagram that indicating that this axis here, the time axis, according to the time, the particle is changing its position. Okay, and the density is created. This is the higher density, this is the lower density. Okay, and accordingly we can create a graph to simplify this thing, that higher pressure is here and it will get started from the zero position. So when the time is here and at this point, the time, let us consider that this is the zero time. Okay, from where we have started the counting. Okay, so this is the zero thing, and then with the 1 second, 2 second, 3 second, likewise the particles get their types and the position changes. Okay, so the wave is formulated accordingly. So what is happening? High pressure is going to be created, but it is not just created like in this manner, just in a second. Okay, it will take time. So that is going to take time, and that is uplifting it like this. And now here we are having at this point that the highest compression, highest pressure value is generated. Now after the highest pressure is getting, now we are having the rare part. It is again shifting towards the rare thing. So now again it is going to be rare part, and because low pressure is generating, so it is reducing itself, and now again it is like the zero. Like now it is not having any kind of disturbance. Okay, but the other thing that is coming back will again generate the vibration in it. Okay, the energy is coming from here continuously, so that will again boost it, and now the vibration will goes in the negative direction. Why? Because once the particle, let me talk it about only one particle now. Okay, so as you can see here in the diagram, this is the particle. Now see, this is at mean position right now. Okay, so this is its mean position. Now let us suppose that energy coming from the left side, energy is coming from here, so it will get vibrate here. Okay, so we can say this is the extreme position till that it can move. After that it cannot move in this direction, in the right direction. Fine, so this is the extremist point. So zero from the mean position, this will let be the mean time. So mean position is there, yani ki density kya hai abhi? Density is at zero because it is not moving. Now it is start moving. So when it is moving from here to here, it starts moving from here to here, and this is the extreme point and this is the extreme point. Now it is getting back to the mean position because it is vibrating in this direction. Now it is again getting in the mean position and it is again coming to here. Now this body now again moving in the negative direction. You know, it is not just vibrating till here and coming back to the mean position. It is also going there. Okay. So now it is coming to the left side of the extreme position. So now it is going in different direction, opposite direction, and earlier we have made the above graph. Now we will take the turn of below graph. That is why we have made here the negative term also. Okay. So because it is rippling now in the other direction. Now again it is getting the extreme position here, and after that will get back to the real position, that is the mean position. So it will get back to the real position, that is mean position. So this is how we have made a vibration of the particle, and we have shown this in this wave condition so that it would be easy for us. Now it is like very easy that we have shown this is the extreme point, this is the extreme point, and this is known as the amplitude, and the time period for one particular vibration, like from here to here. So this much of time gap from here to here, that much of time is known as the time taken by the vibration. And the density part is all you know, is the density thing, that the compression and rarefaction, how does it work. Now students, let us take one by one the different characteristics that we have seen in this slide only, that how we have created the rarefaction and compression part in a simple manner and in a graphical manner. Now let us see what does the mean of the amplitude. So it is basically the maximum displacement of the vibration of the object from the central position. Okay, and the amplitude become double of the loudness, become 4 times. Okay, I will explain that thing to you. So here is the thing that students, here the amplitude, you know, there are 2 examples, like the sound could be soft and it could be loud sound. Okay, so like a lion is roaring. So lion is having a very loud sound that from 5 kilometers away also you can hear the roaring sound of lion. And like a baby is speaking something, it is having a very soft voice, no? So that could even cannot be heard if the person is standing in front of the baby. Okay, so what is the difference between these 2 kinds of sound? Here is a kind of energy they are providing to the vibration. Like the vibration, the particle is here. This particle, wherever I am drawing like this, students, I guess you are considering this as the particle that is present, like atom, molecule, it could be anything. Okay, so now we have seen that in waves, these waves, sound waves, we have represented with the graphical manner. So this is the extreme point and this is also the extreme point, but in the different direction. So this is, if we are considering this as the positive direction, this will be the negative one. But the thing, the displacement of the particle from its mean position to its extreme position here and to its extreme position here, the distance between from the mean position, like this particle, this distance, let's suppose I am taking it as m, and this distance is also will be m. So the distance part is always be same. Here also, so we can represent like this. So we have represented that this is the maximum displacement it can done, and it will appear here and it will appear here. So this could be m and this could be m. Okay, so now the thing is, here you can see in the loud sound, the vibrations are very high. Okay, see the particle is producing a lot of energy that is shifting the particle to a very high displacement. So high displacement will gives you high vibration. Okay, and if the particle is shifted with a very low displacement means the low sound. So this part from here to here, this displacement, this thing, the distance here to here is known as amplitude. Okay, and this from here to here, this is also known as amplitude. Okay, so the amplitude value for this diagram is more and for this diagram it is less. So that is how the soft sound and the loud sound is get produced. Now students, let us see time period. Okay, as we have seen the characteristics of sound and the earlier part is amplitude. Now let us consider what is time period. As I have told you, the time taken by the wave for one complete oscillation. Okay, oscillation, what does it mean? Oscillation, in previous slides also I have told you. Oscillation means vibration. So for complete one vibration, like a particle is here, from here, then here, and again to the mean position. Okay, like this, this and this. So this complete one oscillation, this is considered as one oscillation, and the time taken by it is known as the time period. And if in case of the vibrations like the waves, we have seen how we have designed the vibration of the particle in form of graphical method. So we have seen like this. Okay, so here what we can observe that from this position it gets started, get extreme position here, and then again to the mean position here, and again to the next extreme position here, and again to the mean position here. Okay, so now this is one complete oscillation. So we can say that this full from here to here will be one complete oscillation. So the time required to complete this thing is known as time, and it is denoted by small t. Okay, like this. Okay, and the SI unit for it is seconds. But students, second is also a very big unit for it. Like in this class, it would be you are studying this second thing. Like the SI unit for the time period is second. That is okay. But in higher classes, when you are going to read all these kinds of waves in a deep manner, you will see that even the parts of second, the fractions of seconds are used to discuss these kinds of waves, because they are so fast. They will, one oscillation is just complete in fractions of seconds. Okay, so there we will take the Armstrong part, Armstrong I'm saying milliseconds. Okay, microseconds, we can use that words also, but ultimately these are also the part of second. So second we are denoting as the SI unit of time period.